So this is Choose Your Own Adventure Postgres 18 demos. Let me start a little thing. Okay, so the way this talk came about, I've actually done this for a few different versions. I don't actually always do it for every version, so you can tell which versions I like more than the others, I guess. But I have done it for 18, and I started doing this because for me, like the way that I learn, like every conference it seems has some kind of like, here's the new features talk, and they show slides and whatever. But for me, like I need to get like hands-on and like do examples and run SQL, and that's how I learn. So I ended up creating all these examples and I turned it into this talk. So this is, it was labeled a sponsored session, so I guess it is, but this will run on any Postgres anywhere. Sort of as proof, this is actually not my regular laptop, so I just built the stuff I needed. I downloaded Postgres.app, which I've actually never used before, but it said it was the easiest way to get started, so I downloaded it and now I have a Postgres. That was actually pretty easy. And then I downloaded this thing, WesTerm. I have a friend named Wes. He makes his own terminal emulator, so I'm using that because the default Mac terminal emulator is really bad. So you need some way to get to PSQL or whatever your thing is of choice. If you want to use another IDE, that's also cool. This does use the PGDay sample database, which was mentioned earlier. It's just a regular rentals database. There's some info. It's on GitHub, which people can get to. If you look for github.com/Exilla, that's me. And so you can see stuff in there. And then the actual file just looks like this. There's a gist, which is these are all the demos in this file. And there's a table of contents of all these different features. And I'm not going to actually go through all of the features, but obviously you can download this file and you can play with the features and do whatever you want. So, which brings me to the first thing is I have a set of features I think I'm going to go through while I'm doing the demos. If you see me skip one and you really want to see that feature, like just yell something out and I will show you that feature also. I won't mind, it's fine. Also, as I'm doing the demos, if you want to see like some kind of experiment or slight change in what I've done to see what it looks like, feel free to yell that out as well, and we can do this in real time. So I think that's all the basic intro stuff. And now, oh my God, it's terminal, I know, with actual code and stuff. So this is where it gets really scary, right? And this is why it is different from all the other things, apparently. So up here, just to sort of explain it, right? So this is my PSQL terminal, right, connected to my database. You'll see the stuff going there. And usually, like, the focus is going to be sort of the middle of the screen where the line is. But I'll be typing, and mostly actually copying, pasting, because I can't type very well, examples up into there where it says PGDay Armenia. And then down here is the magic script file, right? And again, you just need a Postgres 18, get the sample database, and if you have the script file, you can run all these things. So let me jump down slowly. You'll notice here's examples that may come up or not. If you see anything that looks real interesting, mark it in your head and then yell out when we get towards the end, because I might not get to it. So, but I will start with this one, which I think is actually interesting and useful. So this is all new in Postgres 18. And the first one is an implementation of UUID v7. And this looks pretty much exactly like you would think for the initial, right? We get a version 7 UUID. I know, it's amazing. You're like, I've never seen anything like that. So the default UUID that is in Postgres before 18 is a version 4. And like, I don't know, maybe not everybody has this problem, but I feel like I end up in a bar with other database people and we argue about whether you should use UUIDs for primary keys or whether you have to use integers for primary keys or whatever. And most of the arguments for like why you would never use a UUID are because UUID version 4 has certain aspects to it, like randomness, which is sort of useful as a UUID, but really bad for indexes. So v7 gives you basically a sort of timestamp ordered UUID, which means because it is ordered, now B-tree indexes work on it really well, and you get more performance characteristics like you would expect from an integer. So that makes it a much better option if you're trying to do that in your application. And we can actually see this. So this gen random UUID function here, that is in all versions of Postgres that support UUIDs. So that's the existing one, and it generates a version 4 because we weren't forward thinking enough with our naming to realize we might want something else. And in defense, I guess version 7 didn't exist when we put that function in. So But I'm just going to generate 5 rows here, and one will be the random UUID function, and the other one will be version 7. And you would say, like, maybe this looks like they're both just a bunch of squiggly mess and there's no difference. But if you notice, well, I can't actually highlight just one side of this, but if you notice the ones on the right side, it's V7, you will notice that they all start kind of the same thing, right? And that's because the way we're generating this is kind of based on a timestamp. And the timestamps are all just generated as we just did it. So they look, fairly similar, and they will sort accordingly. And again, you can build an index on that. Whereas the other one is completely random, and who knows what that's all supposed to be. So we'll give you a slightly more complex version. Here I'm just using a with query, and what I want to show is I'm going to pull a version 4 UUID, which there's a version 4 function that is now in there as well. I'm going to make this other UUID. This is one I just made up. I don't know how many of you have all dealt with a system where, like, developers, if they don't like the UUIDs that are standard, they just make up their own version of a UUID, and they're like, this will be great, and we can partition this all the different ways, and it makes no sense, but whatever. And then the version 7 one. And you can see there's 2 helper functions in here at the bottom. So I was going to say there's these 2 helper functions where you can get if you pass in a UUID, you can get the version ID back, and you can actually get the timestamp back. So when we do the version 7 ones and they're timestamp based, you can see when they were created. That's one of the other things that people like about debugging with integers. They say, like, it sort of gives you some idea of when the thing was made, because if it's a really small number, like, it was long ago. Well, with the UUID v7, you'll actually know what timestamp that was when it was created. So it's even better for debugging, right? And here, because version 4 is not timestamp based in any way, like, that information just comes back as null, right? There is no timestamp related to a version 4 UUID. I happen to know the way that I crafted that version 1, that it would give me a timestamp. A version 1 UUID doesn't have to have that information. I just made sure it did when I made it. And then the version 7 will always have one. And as you can see, this is on or near today's date. I actually don't know what time zone this laptop is in. I'm not even sure I know what time zone I'm in. They're definitely not the same, but you can tell that that was very close to today. So hopefully that explains that a little bit. And then we'll do just one more UUID example. And this is actually, there have been, if you were on an older version of Postgres and you wanted version 7 UUIDs, there were some extensions that were out there that could do it. And there were even, I think the most popular ones were actually, like, written in PL/PG/SQL. This will definitely be much faster than that because it's written in C and it's in the internals and all that. So, and again, like, here's sort of a query. I'm just grabbing 5 different UUID v7s, and I'm grabbing a little bit of extra info on these, and you can see the timestamp, right, I've extracted out, and the v7 in there. So, and you'll notice these are, because I did them all in one statement, they all get the same timestamp, right? If I had done them one after another, you'd see different timestamps. So, okay, that is UTC. There you go. Really? All right, I'll take your word for it. By the way, he's leading for getting the special prize, so. Because that's, I knew he was going to say something because he wants that special prize. So good job on you. You're now number 1 in the list. So let's see, skip scan. Yeah, okay, let's do this one. So we'll do skip scan. I mentioned this earlier. This was one I really did like in 18. Let me just show you the film table real quick. So actually, you've kind of seen this because the other talk used the same demo, so that was nice. So it's just, right, a bunch of information about films, the release year, the languages, the rental rate, and all that stuff. Here, I'm going to make an index on the rating of the film, and in this case, rating is, where's rating? Is this column here. So this actually uses a custom type. So you can do this with a custom type, and this custom type is called MPAA rating. So it's like G, PG, hopefully you guys have that, R, right, whatever. So I'm doing it on the rating of the movie and the length of the movie, so how many minutes the movie is long. So this is an explain plan, and what I'm trying to show is if you do, like, where rating is PG-13 and length is greater than 120, we do this bitmap index scan, which will then allow you to pull this. And I'm sort of doing an equals query on the one side, right? So I only want this one specific rating, and that's sparse because there's only like 5 different ratings you can have. I don't actually know how I would show you that, but trust me, there's only like 5 that you can have. Oh, this is it. Let's do select distinct. Okay, there we go. All right, so we select distinct radius. So these are the 5 different ratings you can have. And I'm trying to query on them where I just want the PG-13 ones that are more than 2 hours long, right? And so that's what this explain plan is showing you. And I'm going to do this different one where I'm just now going to grab the ones that are longer than 3 hours. Right? And you can see we have to do a sequential scan on the film. And the reason for that is our index is on rating and then length. So we can't actually see, or we can't actually use an index to get that information because we're only looking at the second column of the index. Right? So that normally would give us a sequential scan on the table. And on a large table, obviously, sequential scans are bad. So what the new feature does is it actually allows us, oh, you know what I need to do? I need to analyze the film table. And now I run that, and I still get a sequential scan. So what the new feature does, which doesn't seem to show in this demo, because demos, they never work, should allow you to actually get an index scan on that second column without having to go to the first one. And I think the problem is actually this table is too small to do that, so that's kind of odd. I feel like that should have worked. So we're going to try to force it. Hey, look at that. Yes, so on an older version of Postgres, this actually wouldn't work, right? Because it couldn't actually access the index in this way. It would still have had to sequential scan it. So somehow you've read the secret copy of the notes for this demo and knew how it worked. So I think he's actually ahead of you now in the, just so you know, because he fixed the demo, like that's even better. So now we actually can use that index. And again, we're only looking at the second column in the index, right? We're able to scan on the index and grab the data and pull that out without having to do sequential scan. So that's a big improvement. In older Postgres, you would have actually had to have 2 different indexes, right? So you might have the dual column index, and then you'd have another index just on the length column in order to get this kind of a result. So now, if you're on 18, like you upgrade to 18, and you could probably just drop that other index and just roll with one index, which is better for storage and buffers and all those things. So that's kind of the reason why I like that feature. The performance could be different. So if you have a dedicated index that is only one column, arguably that should be faster than a dual column index. But if you have queries going on both sides of it, like there's probably a reason you had the dual column index to begin with, then it's really more a question of how much of those index pages are in memory as to how fast they will be. And so if you're only using one index for both, it should probably be pretty similar, right? It might be slightly slower, but so you might have to test that, but generally speaking, the fact that you can get more of the index pages into the buffers should give you the performance boost you're kind of hoping for. So that is a good question, though. Yeah, obviously could be a slight difference in performance. I'm skipping casefold because I'm American and I don't have to think about weird letters. No offense. Let's talk about time in vacuum. This is actually a good one, also. So time in vacuum. Going to graph. So there's a number of columns that were added into PG-stat all tables, right? So PG-stat all tables normally shows you like different statistics like inserts and updates on your table. So we've added in columns total vacuum time, auto vacuum time, analyze time into that. And the number that comes back, just to note, it's in total milliseconds. Hey, look at that. So, oh, well, you know, auto vacuum, it does stuff even when you're not doing anything. So there are some of these things have been vacuumed, I guess. I didn't vacuum those, I don't know. So here, as you can see, so remember, this is milliseconds that have been in there. If I were to vacuum, I don't know, let's try to vacuum like actors, maybe. And then run that. So you see now vacuum, or actor jumps to the top because the total vacuum time is the highest on that. So you can now sort of track that over time and see like which tables are being vacuumed more often. There's a few more bits to this. Vacuum delay, let's see how this works. So this one you have to actually activate with this guck that is track cost delay timing. So I'm going to first show, by default, this is turned off. And then we're going to turn it on. And this is going to show you, so when you're running vacuum, but more likely when you're running auto vacuum, you know, you can mess with the cost delay settings. And for auto vacuum, generally what that does is it tries to prevent your vacuum processes from saturating your I/O. So adds these like little delays, like little sleeps into the process. But before 18, knowing how much time, like if your vacuum took an hour, you don't really have any idea how much of that was like actual work and how much of that was when it was sleeping, right? It's like somebody who works from home, right? Like you don't know how much time they're actually working and how much time they're sleeping. They're obviously working from, if they work, like, it's like me, I work from home, I'm always working, I'm never sleeping. I'm not fixing the bugs in my demo, but I swear I'm always. Anyways, enough about that. Okay, so we can vacuum for both the actor table, and this is the actual field up here where it says delay time. Now, obviously, this is super fast because it's like on a laptop and it's small data. So the delay time there was 0, but, let me show you this first, I guess. We'll do both the vacuum and the analyze. Right, so delay time is 0, there's really nothing in there because it's so slow. But I can set my vacuum cost delay higher. So I'm gonna set it to 100, which is to say that now, cut that one myself. So if I set the cost delay higher, right, to 100, so now it's like every time it starts to run, it will actually inject this little bit of, microseconds of sleep in there. And I'm also gonna put a limit in there. So I don't want it to go over 1 for the total amount of cost delay. And now when I run this, so you notice like there was a little bit of hesitation in there, right, when it ran. Like it started to go and then it stopped, and now you see the delay time actually went up a little bit. So it was 500 milliseconds of delay time. So that took a little bit longer than the first one because I've added cost delay in there, right, which is the point of what that is. But now you can actually see that that's what's going on if you look at your vacuum output. So again, like this is, some of these features, like some are big things like, in theory, UUIDv7 is a big one. A lot of application developers have asked about that. And it's easy to see how you would use that in an application. Some of this other stuff is like just trying to expose what is going on in the system because you're trying to like debug performance and operations, and you can't even see what is going on, right? So like you have to actually add some stuff in there to see that. So we focus on that a lot within our team. There's a couple of us who've like fought a lot of battles, and so we focus on that. I guess I could show this one. I was actually talking about this one earlier today, this vacuum truncate. I actually think they should switch the default of this. So what vacuum truncate does is when you run a vacuum process on a table, right, so it cleans up the pages in the heap, and when it gets to the end of the process, if there are empty pages at the end of your table, so what they don't tell you, I guess, it probably is in the docs, but nobody reads that part. What they don't tell you is it takes like this like quick little like spin lock on the disks in order to remove those pages. But the problem is like sometimes there's like these weird corner cases, especially like with replication where you can find this for sure, but there's other cases where that little lock like ends up having to wait on something else, and it causes like a significant slowdown where it just waits for the lock to finish to get rid of those pages. The reason why this setting exists, and it has existed in the vacuum command itself for a number of releases now, where you could do vacuum like actor, truncate equal off as a parameter. That exists because for a lot of workloads, even if you are able to remove a few pages on the end, like you're just gonna fill those back up again with data, right? So it doesn't actually buy you much to remove those off the system. They'll just be marked for reuse, and then as more data comes in, they'll be reused. So getting rid of them doesn't matter. What adding this guck does is it allows you to actually set this per table instead of having to do it at the vacuum command level. So then auto vacuum will pick it up and will honor it, or you can do it system-wide and just make the default on your database to be vacuum truncate equals off, which probably is what I would recommend. To me, like, it sounds like a good idea. Oh, we're gonna get some disk space back, but like realistically, you're probably not. You have a steady enough workload or a growing workload that you don't really recover that space. It's very few people that actually have like a shrinking level of workload, right, where they delete more data out than otherwise. So that's vacuum truncate. These are some simple ones. So we've added, again, just sort of adding more stuff in there so you can see what's going on. This one is get backend IO. So this is actually per backend statistics. Right now, this is actually one, I remember seeing this at Oracle like years and years ago, where you would use like a trace plan, like you'd go run your query and then you could see what happened on that individual query right? When it came to like back-end IO operations and things like that. In Postgres, there was no way to see that. If you look in the PG stat system, that's accumulated data from all backends. So you don't really know what's going on. So what we wanted to add was the ability to like, if I just create a new connection, I have my own process, right? In theory, anything I run on that process, I should be able to see that data and understand better what's going on with that specific query. And now these functions kind of give you that ability. And as you can see, there's all kinds of data in there if you want to look at it. Read time, write back time, stats reset time, like fsyncs that are going on within the data. So there's a bunch of stuff in there, right? And obviously, like the stuff is in the doc, so if you feel like you want to go look at that and see what each field means, like, you know, please do so. But just being aware, like that function has been added. We've got some similar ones, so again, we can do that for like backend wall. So if you're using, like if you're doing read queries, right? If you're doing read queries, you're going to see all the select stuff and whatnot. If you're doing write queries, those writes have to generate wall. So you want to see the wall statistics for those queries, right? This will show you that kind of stuff. And I've actually generated some wall, I guess because I was doing those analyzes and vacuums. So I haven't actually updated anything. By the way, in the script, so this probably is obvious, but these are actual, the links to the commits for those specific features. So if you're like looking at this and you're still not sure what it does, by playing with it, you can go read the commit that shows like, here's the message that was in there, and actually look at the code changes that were in there. So since I always have to look this up and get the commits anyways, I figured like I should start including that in the demos. This is a great feature that I'm going to skip. Get ACL, I'll explain what it does. I'll skip the demo. It's kind of complicated. It's very niche. But basically, the very last piece of this is this query here, which doesn't even really fit. Right, so it's all this stuff here. And it's the specific part that's useful is this PG get ACL. What that allows you to do is you can generate basically a list of all grants that a given role has on any type of object in the system. And in fact, on every object in the system. In older versions of Postgres, you basically have to do this like one type of object at a time. So you get like, what are all the table permissions I have? What are all the view permissions? What are the function permissions? Now we can actually do that and just say, what are all the permissions that I have? And it will tell you, you can do the query and it'll say like, well, here's the table, the function, the views, all in one query. So if you're building an admin interface or something like that to Postgres, this is a lifesaver. Most people aren't doing that, I guess. I don't know, maybe with AI, everyone will start doing that, but so that's another one that's in there. I think I'm gonna skip that one. Let's do CRC32. This is a pretty quick one. So basically this is a CRC32 function that's built into Postgres. Again, I think there have been extensions that do this in the past, but now we have one built into the database. And basically all we're gonna do is we're gonna create a little 32 checksum, right, on our title field in the film table. That's not gonna work. And I think in older versions, like you might have used something like hash text to do the same kind of thing. And one of the ideas behind this is that if you have like very long text fields that you want to index, like that's usually not that efficient of a way to index them. If you create sort of a numerical representation, so in this case, like the CRC32, you can index that checksum, right? And then that'll be fast because it's an index on a number instead of an index on text. So that's basically what I'm doing here. I alter the film table. I just do a generated column, and I actually store that data, which is another kind of more recent feature. Yeah, it is similar to that. So this is a little better because you're less likely to get duplicates. And then I can create an index on that. Right, and so that's super fast because it's just, you know, like a regular index. And then if I wanted to search for something, this will be, I don't think this is actually gonna work. Film, where description. So instead of searching for the actual long string of text, so this one, basically the idea is, you can see what I'm querying, right? So like where description CRC32 equals the generated checksum of the thing, then I can use an index query on it, and it's not an index on a large text field. So That could make that type of thing faster if you're into that. I will note, like part of what this also does, you noticed I was doing this UTF-8, passing that in there. So part of with the CRC32 functions is they actually take encodings into account when you're building those out. So that's kind of an extra bonus of that. So, oh. And that says I'm almost out of time. In fact, maybe out of time. And I was going to do like my favorite one. I'm going to do this one really fast. So this is the toNumber function. It's so silly, but it's so useful. I don't know to who. So basically, toNumber now supports the ability to cast things as Roman numerals. I don't know if you're all big fans of using Roman numerals. And I'll skip through this because I'm kind of really out of time. We're going to go super fast. I'm going to insert, I'm just going to go to the end, which is this query here. It actually allows you, so notice this part here where I'm doing this substring of the titles, and I'm doing it on Roman numerals, and I'm ordering by that toNumber. So it could actually, you can order by on the Roman numerals themselves in the proper like Roman numeral ordering, right? Like normally if you try to order on Roman numerals, it's going to come back because it's like ASCII text and it'll be wrong because V's sort before X's and stuff like that. So now we can actually do it. We pass in toNumber, we pass in the Roman numerals, and it'll do the right thing and order it correctly. So again, I'm not sure who actually needs that, but I'm so glad that it's in Postgres now because it's great. And I don't know, array sort, array reverse, new built-in functions. I don't know, I'm out of time. So nobody's kicking me off, but I feel like I should pause. Anybody else got any last minute questions or whatnot before I run off the stage? Yes, sir. He's looking for the special prize. How good is this? Because he solved the problem, so you got to be good.
What's the difference between the CRC32 and the Postgres like hash text function?
So the difference is both. There's a couple of differences. CRC32 will be, let's see, I think hash text is 4 bytes. CRC32 I think is 8 bytes. And CRC32, again, it takes into account the encoding of the database, whereas hash text doesn't, which means hash text is more likely to have duplicates than a CRC32. So that's one of the main reasons that you might want to switch is if you have enough data that's in there that you're hashing that you get sort of false positives back on the duplicates. Switching to CRC32 probably will eliminate that problem. So, and I think it also works a little bit better the more sort of non-standard UTF-8 data that you have, right? So if you're using a lot of like different characters and like in different languages that are sort of more complex, like it'll work better for that as well than hash text, because hash text is just a simpler algorithm to do that kind of work. So.